For over 100 years, the automotive world has been governed by a single, immutable law of physics: energy density. The internal combustion engine survived this long, not because it is efficient, it is terribly inefficient, but because petrol is incredibly dense. You can carry 50 liters of fuel in a plastic tank, and it weighs almost nothing compared to the energy it releases. For the last 15 years, the critics of electric vehicles have held onto this fact like a shield. They told you, batteries are too heavy. Batteries take too long to charge. You cannot defy the laws of chemistry. They told you that the electric vehicle was a city toy, not a serious machine for crossing continents. Ladies and gentlemen, in 2026, those arguments have evaporated. We are witnessing the most aggressive disruption in industrial history. The timeline for the solid-state battery was supposed to be 2030. But the timeline was wrong. While the Western media was distracted by hybrid mandates, the laboratories of China, Japan, and South Korea were engaged in a silent, brutal war for technological supremacy. We are talking about batteries that don't catch fire, batteries that charge in the time it takes to drink an espresso. But before we open this forensic dossier and reveal the winners and losers of this war, make sure you are subscribed to drive&rpm. We cover the automotive engineering news that the mainstream media misses. Hit that subscribe button and turn on the notification bell so you never miss a deep dive. Now, let's get into it. Channel vignette, intro plays here. To understand the magnitude of what companies like Chery and Toyota are achieving, we must first understand the enemy, the liquid electrolyte. In every lithium-ion battery you have ever used, from your smartphone to your Tesla, there is a liquid chemical cocktail swimming between the cathode and the anode. This liquid is the weakness. It is heavy. It limits how fast ions can move. And, crucially, it is flammable. If you puncture it, it burns. But the biggest problem with liquid batteries is that they prohibit the use of the holy grail of materials, the lithium metal anode. If you try to use pure lithium metal with a liquid electrolyte, microscopic spikes called dendrites form during charging. These dendrites grow like tree roots, pierce the separator, and short-circuit the battery. Game over. Solid-state technology replaces that liquid with a solid ceramic, glass, or sulfide material. It acts as a physical barrier against dendrites. This allows engineers to finally use the lithium metal anode, which doubles or triples the energy capacity. This is not just an upgrade. This is like moving from a steam engine to a nuclear reactor. It changes the fundamental mathematics of how a car is built. And in 2026, the code has finally been cracked. Chery, GWM, and NIO. Let's look at the data coming out of China, because it is terrifying for the competition. We must start with Chery, known primarily for budget exports. Chery stunned the engineering world with the Kunpeng battery. They are quoting an energy density of 600 watt-hours per kilogram. Let's pause and analyze that number. The current industry standard for a good NCM battery is around 250. Chery hasn't just improved it, they have more than doubled it. This allows for a vehicle with the same weight as a petrol saloon to carry enough energy for 1,200 kilometers of real-world driving. Chery claims this is not a concept. It is entering fleet testing now, in 2026, with mass production in 2027. But they are not alone. Look at NIO. While others talk, NIO is already putting semi-solid-state batteries on the road. Their 150 kilowatt-hour pack, supplied by Wheelion, is currently powering ET7 saloons across China, achieving over 1,000 kilometers on a single charge. And then there is GWM with their S-Volt division, focusing on sulfide-based solid electrolytes that prioritize extreme safety. The Chinese strategy is clear: dominate the supply chain before the West even wakes up. Now, we must address the elephant in the room. BYD. As the world's largest producer of electrified vehicles, many assumed BYD would stick to their famous LFP blade battery forever. That assumption is dangerous. BYD is playing a 4D chess game. Our analysis indicates that BYD has dedicated a massive, secretive R&D division in Shenzhen solely to solid-state development, specifically for their high-performance Yangwang sub-brand. Why? Because you cannot power a 300 horsepower supercar like the Yangwang U9 efficiently with heavy LFP batteries. BYD is developing a proprietary hybrid solid solution. They are looking for the sweet spot, the safety of LFP combined with the density of solid state. They are not rushing to be first. They are rushing to be profitable. When BYD eventually unveils their mass-market solid-state battery, likely in late 2027, it won't just be for supercars. They will industrialize it at a scale that will undercut every other manufacturer on the planet. Is the rest of the world sitting idle? Absolutely not. In Japan, Toyota is preparing for a do-or-die moment. Toyota holds over 1,300 patents related to solid-state batteries, more than anyone else. Their partnership with Idemitsu is the key. They are focusing on sulfide solid electrolytes. Why sulfide? Because it is softer. It maintains better contact between the battery layers when they expand and contract. Toyota's engineers are obsessed with durability. They don't just want a battery that goes far. They want one that survives 1,000 fast-charging cycles without degrading. They are targeting a 2027 commercial launch with a charging time of 10 minutes. Meanwhile, in South Korea, Samsung SDI is taking a radical, high-tech approach. They are betting on anode-less technology. By eliminating the anode material entirely during manufacturing, they can create batteries that are incredibly thin. Samsung is currently shipping samples to multiple premium automakers, rumored to be BMW and possibly Porsche. This is the premium European hope, using Korean technology to fight off the Chinese invasion. This technological leap creates a massive crisis for Europe. The German automotive industry, Volkswagen, Mercedes, BMW, built their reputation on the complexity of the combustion engine. That was their moat. Solid-state batteries fill that moat with concrete. If a Chinese manufacturer can sell a car in Europe that charges in 10 minutes, has a 1,000-kilometer range, and costs significantly less because they own the supply chain, what is the argument for buying a traditional European car? The power dynamic has shifted east. The battery is the engine of the 21st century. And right now, the engine block is being cast in Asia. Solid state. However, we must remain grounded in economic reality. Will your next hatchback have a solid-state battery? No. The manufacturing process for these batteries is expensive. For the next 5 to 8 years, the market will split into two distinct tiers. Tier 1, the mass market. This will be dominated by refined LFP batteries, like BYD's Blade. They are cheap, robust, and offer good enough that range. Tier 2, the premium market. This is where solid state will live. If you buy a luxury saloon or a sports car, you will pay a premium for the 1,000 km range Badenta Boss badge. Solid state won't kill the electric car market. It will segment it. So, what is the verdict? The internal combustion engine is currently on life support. The one advantage it had, energy density, has been matched. The solid-state battery is no longer vaporware. It is real. It is in testing. 2026 is the year of the prototype. 2027 will be the year of production. By 2030, buying a petrol car for long-distance travel will feel like buying a horse for your morning commute. The question is not if you will drive one, but who will build it? The technology is exciting, but the war for market dominance will be ruthless. I want to know your thoughts in the comments below. Does a 200 km range finally convince you to go electric? Or are you waiting for the prices to drop? Please give this video a like and subscribe to drive&rpm for more unbiased automotive analysis. Don't forget to check out our previous video on the screen right now. Thanks for watching, and see you in the next one.